All right, so today we're going to be talking about is that big enough? Everybody can read it. Visualization. I'm Richard. I think we met a couple weeks ago. Francis is in the back. So we're going to be talking about visualization. Specifically, we're going to be doing this over like 2 R markdowns. The first is just on base graphics. So base graphics is the basic stuff that comes with R. Most of the time people don't use this, but just for the sake of completeness, we get a little bit of it, but for the most part, people use ggplot. And so in the second one, we'll be talking about ggplot, which is from Hadley Wickham's group, the RStudio tidyverse world. So that's the one that most people use. I personally use a lot. So that's the one where we'll also be talking about. So let's get started. I'm going to switch to, no, I'm going to keep like this. All right, so for base graphics, so again, ggplot, specifically ggplot 2, what people typically use to kind of make quote unquote pretty plots. But if we want to know how some of the things in the back are made, we're going to talk about some base graphics. So these are what you can do without any kind of packages being loaded. So if you see at the front, I've set this seed. This will come into play later. That's a random seed. So if you run this, you'll get the same results each time.
Create our own base graphics, like
Yeah, if you'd like. Yeah. Okay. So set seed and plot 1 through 10. So you can see we get this plot, the numbers 1 through 10 against the numbers 1 through 10, right? Straight lines. All right. There's different marker symbols you can use, so you can change what the markers look like. So PCH equals PCH stands for what the point looks like. So 2 is triangle. And then there's a whole slew of them. Where basically these are some of the base kind of symbols that you can get in R. Like, so if you wanted to, I feel like there's something being cut off here, but whatever. So, yes, your squares, your circles, your pluses, your asterisks, your square, your foursquare, and so on. Okay.
Oh, okay.
What's up?
Oh, this is sound.
Okay. I mean, there's one participant on Zoom, and it's me. So, all right. So, give you an example. So CEX changes the size, and so this is kind of showing what the different PCHs look like across the different, 1 through 10. You got the circle, the triangle, the plus, the X, and so on. And then if you wanted to make the points really small, you get like really tiny points, or you can make it really. So, you can play around with that as you go. Any questions so far? Okay. There's also different colors you can use. So, probably go 1 through 10.
I just need Francis help for getting that.
Okay. We'll kind of plot the different colors. If you want, you can also just go blue, plot them as blue, red, 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 blue, not a valid color. So it typically, like, some of these are kind of your standard, like it'll recognize some of the like known, you know, color names, and then for the other ones, if you want to get like really detailed, you can use text codes to get an idea of like a specific color. Okay.
When you do, PCH one.
Yeah.
Sorry, not the table each data. I did me. And all like going down the list.
Basically, so yeah, so what this is doing is it's basically, it's going to be like, it's going to like basically, oh, where is it? It's going to put, you know, this to that PCH and so on and so on and so on. So if you just put in one, it would just map that PCH to all of them. But in this case, it's going to be all right, 6, 6, and 7. So if you wanted, you could do the following. 10 through 1, which is like the different ordering, and you get a, you know, slightly different. So far, so good. All right, marker colors. You can also add text to your plots, which can be useful. So if we plot our 1 through 10, so this is plotting 1 through 10. We're telling it the PCH we want to use, the color. Then we're giving it the limit. So the xlim is telling it how far to plot the x-axis on each side. So it's doing 0 to 11. So you can see here, you know, you got 0 and you got 11 out here. And then we can add text. All right, that's annoying. All right, hold on, I got to run this real quick. There we go. All right. So here, what it's done is basically it says, okay, at x, at these coordinates, so at the x coordinates 2 through 11, and then at the y coordinates 1 through 10, plot the letters 1 through 10. So the first 10 letters. So in case you're curious, I don't know if this has been gone over, but there is a vector, a base vector that's in R that's just letters, which is just the 26, the alphabet. And then if you capitalize it, oh my gosh, the A through Z capitalized. So if we did sorry, you got to run these real quick sometimes with base R. You get the capital letters, not the capitals. Any questions? Pretty
Question.
Yeah, sure.
So if you have a very complex curve, you won't know the exact point where you can tell that you like precisely have
Yeah.
to the plot.
So there it gets a little trickier. In ggplot, there's some approaches that'll do that where you can try to get the letters kind of map to it. Be like data frame, like we'll get into it using these different methods, but yeah, it gets a lot more complicated with those cases, but there are packages and whatnot to try to like put the text near where you want it to go. But again, it does sometimes involve like tweaking where you do have to get in there and like okay, think there, and you have to run it again to get it right. All right.
Change that.
So next, we're going to generate a line plot. So we're gonna set the sample size, n is equal to 20. All right, then we're gonna make x is just gonna be 1 through n. So remember 1 through n. It's just 1, 2, 3, 4, 5. And then we're gonna generate a y. So we're gonna say y is equal to x plus some random noise. So our norm. Have you guys gone over our norm yet? Sorry, I missed the last 1 week. All right. So our norm stands for a random draw from a normal distribution. People know what a normal distribution is, right? The bell shape, whatnot. So this is going to generate a random variable from that distribution with mean 0 and variance 1. So if you look at the guts of our norm, you put the n, which is the sample size, and then it defaults to mean equals 0 and standard deviation equals 1. So there's a bunch of base packages in R that generate data from various different distributions. So we're going to make our y. So y is likely going to be different depending on whether or not you set the seed. Don't worry about it, it's random. But the basic idea is you have, we generate our data and added noise to it. All right, so now we're going to plot x and y. And we're going to say type equals L, so that's going to tell us to make a line plot. And then we're going to add more information about the color, the width of the line. The title of the line is main. The X lab is, the label, the X label, and the Y lab is the Y label. So we get this nice little plot, right? You see bar over here. You see foo. You see plot, and then you see the line, right? And it's not an exact 1-to-1 because we added noise, right? But the general idea is y is increasing with that. Okay. And then if we wanted to add points,
What's LTY again?
LTY is the line type. So I'll pull up basically, you hate to say, like, sometimes but I can never remember any of these things. But yeah, so like it's basically the line type. So 1 is solid, 2 is dash, 3 dotted, 4 dot dash, and so on and so on and so on. And then LWG is the width of the line. Okay. So we can then add points, and this will basically just overlay the actual points of the data onto the plot. All right. So, we could play around with this, we can make it 4, we get this 10. We get this really kind of whatever looking plot. So remember, 4 is dot dash. There we go. Any questions on line plots? Okay. So, here's a little note, the function points, adds points to the current plot. So if you just ran points without anything on, it'll shoot out an error. So if you ever want to get rid of whatever plots, you can either, just put dev.off, and that'll usually close down whatever. And so if we did say, all right, see it in our plot window, we go to dev.off, shuts it down. This will play into account later. Okay. So we can also add, say, lines from a linear regression. So I think there's more of a statistical section following, but do most people know general like linear regression? The general idea is like simple linear regression, right? Y modeled on X. So we have the way you run that in R is this function ln, linear model. And you have your outcome on the left-hand side, your variable of interest on the right-hand side, right? So we run that. That gives us, the classic ln formula. There's your intercept, your coefficients, and so on. And don't worry if you don't have the same result exactly. Remember, depending on whether or not we set the same seed, we may have slightly different y's, right? So if we now plot x, y, we can pass in through this function add line, then like adding a line or the quote unquote linear fit, right, from our model that we just ran. So what this is doing is basically it's fitting a model, it's fitting a line to this with intercept. Oh, is that the printer? Oh, it's the camera. Okay, sorry. Negative 0.03465, and then with the slope equal to 1.01. And then it's going to take that and it's going to make a little line onto the plot we just drew. Any questions, Matt?
What is the M in?
Oh, the M is the object. So remember, M was assigned ln. So we're passing that linear model object into add line. Okay, AB line. So what this has is A, B, HB. So HB is like horizontal line, B is vertical line. And I believe A is the intercept, then B is the linear slope. So if we wanted to, we could say AB line, H equals 15, color equal blue. Right, and it'll draw like a horizontal line on the plot. This can be kind of useful, obviously, if you're like trying to highlight certain areas of your plot, to be like values above this or values below that. And then we'll talk about this more with ggplot. Okay, any questions? And then once we get into ggplot, it's a lot more fun. No one probably believes me about that. So, all right, so we can put multiple plots kind of in the same graph. On the same axis, I mean. So basically, we're going to run that again, right? We have that M. So we got that, what we kind of just did. And then we can generate a new Y, right? So this is basically a new Y where it is, instead of mean 0, we're saying mean 0.01 or 0.01. And we run it again, and then we'll get kind of a new result. So let me run this. So you can see here, let me add some more noise. Let me make it a little bit different. This shouldn't work. Hold on. Still not as much difference as I would like. Okay, there we go. That's a little bit better. All right, so what we have in the really not fun green is that second Y, the Y that we created on line 99. That is X plus noise, right, with mean equals to 4. Okay.
You might want to change your camera settings.
Oh, what's,
Issue. That's the one you try.
should I just turn it on?
If you go to video. And check, yeah, try to check the recording background.
I mean, that's gonna, we can get basically us in the middle of this,
Yeah, there was a way to connect to that.
which is like an infinite loop.
Yeah,
Sure. So, I'll just
okay, I think it's fine for now.
I'll just turn off my video. Oh, am I not sharing the screen?
You're not.
All right. All right. Oops. Sorry. So the first half hour of this, if you ever want to go watch it again. it's beautiful. All right. So going back to this, the orange, right, is that new one. You see how it shifted up, right? Because it has a higher mean. And then the red is that kind of original that had mean 0. And you can see the two lines and the two quote unquote fits on top of each other on the same plot. Any questions? Okay, histogram, right? Histogram is like a distribution of the data. Give you an idea of what it looks like. So, this is what our Y currently looks like. And then you can tell it to like break it up more. So we say breaks equal to 15. I'll add more kind of breaks in the range of your data. So let's see, 1, 2, 3. Yeah, there should be 15 little spaces here, including the where there's none, the blank. Okay, bar plots. It's just called bar plot. And then we can also do box plots. So here, we're going to make a fake categorical variable. We're going to sample from 1 to 3 20 times for replacement. So we have G, right? 2, 3, 2, 3, 3, 3, blah, blah, blah. We do table of G that'll tabulate it, right? And it should be roughly a third or so, right, in each. Not exactly a third because there's 20. But no, 6, 6, and 8. All right. Then we do Z. This is going to be a random noise, and we get a box plot, right? So this is a box plot of G, different levels, and Z. All right, and if you wanted to run this again, GL. Right, and it would put the A, B, and C down there. Okay. It's not the same because GL and G aren't going to be the same, right? Because we did this sampling. Because we sampled, it's going to be slightly different. Any questions so far? No. Everybody good? I'm moving too fast. Slow. All right, great. Next, we're going to talk about QQ plots, stand for quantile plots. So this is basically to get an idea of kind of its cut points for what values a distribution achieves, say a bigger probability. So like a quartile would break it into fourths. The most common quantiles are percentiles, where a distribution is broken into 100 pieces. The QQ plots the observed quantiles of the data against some known distribution, say the normal distribution, or so has anybody ever done a GWAS or genetic genome-wide association study? You'll see these against like p-values, right, against a uniform distribution. If the data comes from some known distribution, you'd expect it to kind of lie on the diagonal. All right. So we're going to create 100 values from a standard normal. All right. So you can see it kind of looks, yeah, roughly bell-shaped. Okay. And then we can do a kind of QQ plot of this. So there's a QQ norm, which will plot it against a normal. Right. So theoretical quantiles, and then what you observe. Then you can add a line to that. And you know, you can see kind of a nice kind of follows along pretty nicely. Any questions about that? You often see these, you're doing like a linear regression, right? You assume the data is normal. So you look at the errors afterwards and see how much they kind of fall along this line, because if the errors are normal, they should fall along the line. So, all right. We're gonna next look at some multiple plots, how to have like multiple plots in a window. So the way to do this in base R is a lot easier in ggplot, is you have to kind of set it. You have to set this kind of command prior to running it. And it's this PAR, like parameter, MF row, and you say the number of rows and the number of columns. So here, par MF row C22. This is going to basically make up a grid, a little box, right? Like a four squares. And then it's going to just sequentially plot what you put in there, kind of to build it up. And then once if you try to plot it again, it'll just restart over. So let me show you what that looks like. All right. Okay. So you see, we have the four plots. Right? We have the first plot, the just scatter plot, right? X versus Y. The second one, we have the line plot. And then the last one, we kind of had the bar plot, and then the bar plot of Y. Any questions about that? And then you kind of reset it to 1 and 1. This PAR in that row equals C1. All right. Any questions about that? Okay. So we're next going to talk about saving plots. So when you save plots in base R, the way you do it is you have to specify what you want it to output in. So PNG stands for a PNG file. There's JPEG, there's TIFF, TIFF. PDF, and so on. So you say, hey, I want to make this figure, and you specify the path. And then you run the code, and then when you're done, you say dev.all. So the sorry. Okay. And if we try to go in, look at this should work. Okay. All right. So you'll get this figure, which is the X and Y that's kind of saved in your phone. And you can kind of change that around or what you want, so you can leave it fine. Right.
Oh. Can you find the file version?
Yeah. What's up?
I just keep getting an error.
Okay. Oh, make a little file, make a directory in the file with the visualization. That's big. What's the path that you have?
I'll make it a folder. Yeah.
Oh, okay. Yeah, it's not the same as the directory, so that's. So, yeah, can you set your working directory into that file? How to do that? Okay, that's, so let me just run that real quick.
Yeah, if you just make a fix folder.
Yeah,
In the data sign.
so,
Yeah, it's like a visualization.
so if you go to session.
Oh.
Set working directory. And then you say to just like the source file location. It'll put you in there, and then if you create a. If I delete this, do I get an error? Yeah, so then you, once you're in there, you have to create a directory called figs. Then this should work. So is that? Yep, yeah, then. There's something in there now. Awesome. So again, you know, you have to kind of make a folder, in the new folder in there. Apologies. Are people getting that?
What is the long words?
It's oh, that's saying that's the same, we're closing it. We're closing the connection to that file. So anything you put in after that will not get written. To that file. Yeah, it's like it comes from the dev.all.
Yeah.
I think I do this. Actually, I don't know how to turn that off. Yeah, so the null device is basically the output of the dev.all, to say we're closing down the device. Are people able to create a figure? Okay. And then, in our markdown, you can kind of add it back in. I'll run this and we'll see what it looks like. All right. So submit this. Right. So it reads it back in. So this is like markdown code and basically telling it, put that image in fix title lm.png and put it into this document. So if we switch to visual mode, it should show up. So this is what that output of that code. So you can see it's kind of popped it into your document. I'm going to switch back to source editor. All right, any questions before we get into exercises? All right. There's 7 exercises here. Go ahead and give them a shot. We'll be around if answer any questions. Go from there. Oh, yeah. Right.
It's usually, I think it's nothing like question.
I mean, it's, yeah, I know. Plugged in. You know, hear too much.
Okay, yeah. I think it's fine. The sound seems better up here than it was there.
How can you not hear me?
Oh, no, I can hear you.
Oh, that sound.
Yeah.
Was last week. So last week.
Last week. But just for the launching away. It's a nice change in this. I feel like flying.
Yeah. Said we could remove the base on it.
You kind of like. Just because there's not enough material. Are you anything this weekend? Having small.
So.
Right. It's hard. So yeah, we can purple that.
You will. You're targeted.
Yeah, okay. Oh, it's kind of close, yeah, you know what you're That's good.
Yeah.
Oh, that's like that, I never. Variable, so if you do. You're doing. Yeah, capital P, but you can always. Well, I defined M the first one. Well, yeah, but and that's the shape. I did that, I got it. Change. I just did. That's why. Instead of- Yeah. But I don't know. Because most of the data is new on my line, so.
I think she. Pushing the deadline, so. That was November. Yeah. Are you looking for it? Yeah. Yeah, that's for. Yeah.
Okay, now I got you. I feel like. Okay, that's what I think it's for something. But.
It's today.
Yeah. That's, no. Is there a bunch of
Questions.
I had it.
Yeah. But I also don't get the. You go to many sessions. Oh, wow. Yeah. It was a lot worth it. Yeah.
And there are some like real small ones. That's just yeah. You took that X, Y. Okay. Wait, no, she never.
Oh, yeah. So you have to define X and Y either using a vector or just typing in iris dollars.
Yeah,
In your-
we did.
It is alright. Yeah, for flat and then. you have to put it in the M vector LM, like they did above.
Okay, I did that.
The best fit.
So,
But did you identify X and Y in that M variable? Yeah. that should be-
did you have them backwards? Or maybe I have.
Oh, yeah, it's Y, X, yeah, it's Y and then X. Put it back.
Yeah, so that one. Oh, yeah, I think that, thank you.
Yeah.
I have it backwards. Like, I mean. Which is why. Well, yeah, like, yeah, yeah. And for one thing, read random. I don't know. There's always so many, oh, you might think it's happening over, I don't know. I think that's what I remember, no, it's from, oh, I haven't even. One, but it's. What was in.
Oh, yeah, no. Oh, it's like you. Yeah. Type in your data. Yeah, get you done, sure. And then put your data. Yeah, you like desires.
Or maybe like the first.
Oh, first sentence. Okay, yeah, you can get rid of data and just type it in. Yeah, and then type in your data frame. With the numbers.
Yes.
Okay, great. Yeah, your entries. Then you should see just the first. Yeah.
Okay. Thank you.
Yeah, no problem. Yeah.
Okay, but it's taking your formula, what?
Oh, I mean, so. That's getting. The statistical question of what you should use model, right? And then if it's a predictor of why. So for now, I would.
Right, so. This one.
Read too much into it, but it's basically right, like shield and your regression. Right? That would be the idea. For why, that's for being associated with why. So, but for this one, we're just kind of using it without really. We know how to thought.
They're just.
Yeah, so like left hand side is the outcome. Right hand side is the variable. It's a formula, so that's what they're hiding it. Have them bring it in.
No, you just put the.
Yeah, basically, yeah, but what is a variable for predictor? All right, let's go ahead and go over the answers now. All right. So, first off, first question. So we'll go over this and then we'll take a break and then we'll come back and we'll do PG plot. All right. So first off, plot a scatter plot of petal width versus petal length from the iris data set. So do that. Get R open. Plot. So we can do plot iris petal length. Petal width. Right, and you get this. Remember this? I've drank so much of the religion of tidyverse that I forgot a lot of the states are, so. Nope. So never mind. Yeah, okay, that doesn't. All right, so iris petal length. Petal width. So now we're going to add a best fit line to the plot. So first we have to fit a linear regression, right? M. So petal iris petal width. Petal length. Right? Gives us this. Plot. Adds the best fit line to that plot. Question? Then also for this M, we'll get into that then. All right. So next, create a box plot of petal width by species and another box plot of petal length by species. All right. Make these plots sit side by side. So I'm going to make this a little bit bigger with this big height. So actually, I'm going to make the width. All right. Par MF row. I'm going to start by side. Box plot. Petal dot width. Iris species. Right. Yeah. Seen side by side. Oh, yeah. So you see petal width by species over here, then petal length by species over here. This is cut off because one of the species letters is very names is very long. So we can also do this. Like so, they have to kind of stack on top of you. So, any questions so far? Okay. So create a scatter plot of petal width versus length. And color / change symbol by species. Iris, go petal dot width, iris, petal dot length. Then I believe. Oh gosh, I have to remember. That's not. Yeah, there we go. Shape. CH. Everybody, forgot how to do that part. So what I'm gonna do is, there's probably a better way to do this, but I'm forgetting right now. Which I apologize, I'm just gonna hard code it. Sorry. Sorry. There we go. As that. Sorry. Wondering. There you go. Okay, yeah, just out of curiosity, does anybody remember a better way to do that? No? All right.
No.
So, yeah, so we look at new species and we go iris species. You can see, right, kind of a one-to-one mapping. So, any questions on that one? This will be a lot easier in a ggplot. You could also do something similar with colors, right? If you didn't want to use the colors, and instead of 1, 2, and 3, you'd put like forest green or FF 4 or 5 or whatever, some hex code or something, and then you put that in color. You get different colors, whatever the default is here.
Oh, so a question.
Sure.
So because this color is being randomly generated, but how can you specify the color? Like,
Yeah, so what you would do is you would do something like this. Quick, give me 3 colors. Blue.
Dark orange, it works.
Yeah. Your word for it. One more.
Pink.
Pink. All right, let's see if this works. It's gonna be very embarrassing. It won't be. Look at that. There, now, so that's how you could like manually set that. There's a lot of different color schemes out there, lots of resources out there. I think the silliest one I've seen is one based after a filmmaker. Then there's other ones, like if you wanted to say how to have your plot be okay for people who are, say, colorblind, there's information out there about that, what schemes you can use. Okay. All right. So next, add best lines for each species to this plot. Code. So, this, I guess, isn't technically fair because I guess we didn't go over this, but for that, I apologize. Here's how at least I would do it real quick. There's always probably a better way. There's a million ways to do everything in R. So I'm just going to put, so what this is saying, so I might as well tell you all how to do one of the ways. So if you specify data, like a data frame, and you just specify the names of the columns, R is smart enough to just be like, all right, petal width onto petal length, right? So this will give kind of the same result, right? Whoa, not that one. Right. So, and then if we want to subset, we can say, hey, subset where species. Length. No, that's not right. Virginica. This will be the result of just running a regression within the Virginica species. So we can do this for each one. I'm going to copy this back in here. M0 color equals, so M0 is Virginica, say pink. 1 Cosa blue. Then versicular is dark orange. So RNA screw up. Run. So you see here 3 different lines, right? We've got the dark orange, the pink, and the blue. The blue is from the regression that's just run on these points. The dark orange is just from those, and the pink is just from those. So this is like the adding multiple lines. You see it goes out really far, right? It's like, well, what would it's trying to predict? All right, if it was so M0 is Setose, no. Blue is, Setosa, so it's trying to predict, all right, it's for somehow you had a Setosa plant that had petal length of 7, what would its petal width be? So that's why it's drawing all the way out there, but that's not realistic, right? This is getting more into like maybe the statistics talks later, right? Where you kind of want to keep your prediction within the range of kind of your observable values when you fit these kind of models. That's for another session, probably. Any questions on that, or did anybody do it a different way? I'm always kind of curious. There's so many different ways to do everything in R. And apologies, that kind of involved some stuff in LM that maybe we didn't go over. You could have also done this right with having the iris, having something like this. And then, you know, iris species equals kind of this kind of like long convoluted thing. So, and then you have to put something. All right. All right, so save this scatter plot to a file called pigs iris.png. PNG, pigs, slash, iris.png. I'm just going to copy this down here. Can people hear me with the mask on, or is it kind of touch and go? All right, great. I'm keeping it on then. All right. Go into files, go into pigs. Look at that. Get our weird little plot now. All right. Now read this file back in and display in the markdown. So if I can't remember it off the top of my head, I'm just going to go up here and copy what we have and change the name. And it's still switches. Right. So for visual mode, you can see it's kind of plopped it in there. Any questions? No? Well, if there's no questions, I guess we can take a break. Maybe 10 minutes, usually 10 minutes, right? Say 10 minutes. All right, let's take a 10-minute break, then we'll come back and we'll start doing ggplot. I'll try to upload these stuff. Oh, the color right there. Yeah. You got it. Yeah, no worries.
I think I just thought like lots when we started. Quite a lot of.
Yeah.
Like probably.
Yeah, all right. So so what I was doing here was I'm making a new vector of new species that's the same length as the species. So like right when this starts, so like the same, right? And so then it's, if we look at it right like 1:1, right? Table 50.
Why?
So this was how I manually set, because when you do the PCH, it has to be the same length as the vector, that's the thing that you have in. So what this is doing is it's going to slowly change between species, such that Setosa in the new species is now going to be assigned to 1. We run this. You see now it's 1. And we're doing this because I want Setosa species to have PCH1.
So PPH, I have. What do you found?
It's these samples.
Oh, okay. You're not trying to rush the
Yeah.
type of. Oh,
Yes.
Okay.
And so I just kind of did that. Again, there's likely
I think.
faster ways. Definitely in tidyverse there is. So that's what I'm doing. So Jen, I do for secular. Right, you can see it's going down. And then the same I did for color.
Okay, cool.
Does that help?
Yeah.
Yeah.
Oh, and then the add. Oh, yeah. I don't know why. I don't know. I don't know why.
Think here.
It's increase disclosures. Yeah, it's so ER.
Oh, okay. Thank you. Yeah, no.
Setosa. Yeah.
And then if I just.
So that one is, you don't have a comma after the iris. Like what? Oh, I.
Oh, okay, that's because would it work instead of having data here to do like the Irish translation?
Yeah, but then you have to put iris spelling.
Yep. Giving me an error of the term. Yeah. I'm not bringing it. I don't.
But it's still not, I don't know, there's more things that you can.
Oh, so you call it one.
I had it for those I told this I was going to know that. That's right. Yeah.
Yeah. This was, there's just an error, but I think it's from. Yeah, that happens when it's-
Oh, yeah, try pressing the, running it all at once.
Oh.
Yeah, it's, you know, it's finicky. Yeah, no worries.
Okay.
So just do that into the workout.
Yeah. So here's the thing. And goes around. So, no, it's right.
Oh, don't put that. It's not an art. I'll be honest. Not every day. And then there's something that it's not really. So it, yeah, it won't count. So either when you compile the code, you'll know to do that, or you go to like a visual mode. So you switch So it's like a marketing thing, which is here, that's not really hard.
No, I don't know. Somebody told me, I think that we was very good on that. Oh.
Yeah.
I know.
Oh, you're not the shirt.
Yeah, showed up.
It's very.
You can make.
Yeah.
That's what she's on there.
All right. Let's move into ggplot. Let me run it. Again, I'm also going to just start a new kind of empty out my R section, right? Remove everything. So there's a couple ways you can do it. You can do session, say restart R, which just restarts it. I sometimes just do move list equals LFF. That removes everything from the local, like all the objects I've created, all those M0s, all those M1s, all that new species dot call and everything. So it's empty, and then I'm just going to do Control L, kind of restart it and restart with a fresh new page. Well, not page, but a fresh new terminal. So, all right, let's get into ggplot. I'll also briefly talk about some other stuff. I put GT here, but there's nothing in there about it, but we'll talk about. All right, so graphics with ggplot. We're gonna load some of these libraries real quick with tidyverse. This time deck, I wasn't sure actually. Did anybody else get this? Oh, run it again.
Yeah.
Yeah. So, all right. So this is just some general stuff about width. I would just ignore this for now about like plot width. All right, so we're going to simulate some data, start plotting again. I have my seed that I'm going to set 5, 4, 3, 2, 1. I'm going to make this X. So our unit is a random uniform distribution. So people know what a uniform distribution is. So it's something where like so it's a uniform distribution from 0 to 1. I'll do 0 to 10. It's easier for me. So that would basically mean like if you drew a number from 0 to 10, the probability that you got something between 2 and 3 would be the same as the probability that you got something from 7 to 8, right? It's like it's uniform over that whole scale. So, you know, we plot this, it kind of looks, it's not exactly, but it's kind of like flat, you know, kind of across the uniform frequency across everything. So, and then we sorted it so that the lowest values are at the beginning, and then the largest values are at the end. All right. Now we're going to generate a y, and we're going to generate y. It's going to be equal to x squared plus x plus 3 plus 0.2 times this r norm n. Right? We're going to make z. And then g is just some random factor. So we're going to be sampling from 1 to 4 in times with replacement. 1, 2, 3, 4. And then we're going to make a little tibble. We have our tibble with x, y, Z and G. All right. This is going to be something that we're going to be passing. ggplot works with data frames, so we're going to be passing these data frames to ggplot. It's kind of like we do in tidyverse. You remember tidyverse? How do you like chain stuff together? Yeah.
When I'm looking in how I can tell if I'm not getting machine numbers, I'm just getting like 1, 2, 3, 4, 5, 6.
Did you rerun all this?
I don't think I.
Yeah, that's likely it.
Okay.
And you will likely get slightly different numbers depending on whether or not you set the seed at the beginning. So if I set seed equal to, I don't know, 1919, you get different numbers, right? Just the random seed that kind of sets it so it can be reproducible. All right, so ggplot. So it uses this grammar of graphics convention, which I'm not super familiar with, but Janice has provided a link with some more information. So the main things that you kind of pass on are the data source, the data frame or tibble, a map, the data elements to the visual characteristics, type of visual elements, layers, facets. Facets is basically how we're going to get like multiple plots. So you remember we did that par and that row 2, 1. In ggplot, we use facets to kind of get that same thing going on. Scale to control how the mapping is made. So remember we did that new species dot call pink, blue, or dark orange. Scales is how we do that in ggplot. Statistics to add summary data to the plot, and themes to define how the plot looks. All right, so let's start with a simple example. G0, and we're going to say ggplot df AES, and then we're saying the AES is the mapping, and in that mapping we're saying x, going on the x equal to x, and y is equal to y. All right. And we get nothing, right? And that's because the way ggplot works is we haven't added any additional like layers to it. So we only told what mappings we want to use, i.e. like the x-axis and the y-axis. If we want to add anything, we have to use geom. So we define G1 as equal to G0, and then we say plus geom point. Okay. And so now it populated it with all the points, all 100 points. So we have for y and x. Okay. And so very briefly, the way that this all feeds into, you could see this in like tidyverse, is you could do something like this, df. You go df ggplot AES x equals x, y equals y. So you see we have the pipe operator, which is basically saying pass this data frame to ggplot. Then we put the mapping in there, and we get the same plot. All right. So we can then add, say, like polynomial fits or linear fits to these using geom smooth. And so this is a much easier way to do what we were doing, right? Like adding those lines. So we take G1. So if you remember, G1 is G0 plus this geom point. We say geom smooth. We tell it what method we want it. We want it to do a linear, use LM. You could also pass in like lowest, like different smoothing regressions. And then we tell it the formula. And so we say the formula is y as a polynomial of x with up to degree 2. So that's going to be equal to x plus x squared. So you can see here, this is x, and this is x squared. So we run this. P2, oh, look at that. Added a best fit line to the plot, and also it's added a confidence interval around. Any questions on that? We would get the same result. Watch this not. If we did say just x plus x squared. Oh, no, we don't. Never mind. Disregard what it just said. It is wrong. All right. So yeah, so we get that polynomial. Any questions on that? Okay.
Which part of the code telling this is pure that we want a confidence interval, or is this just?
I think it just defaults. It's a default option. You can turn off, I forget the exact approach.
Can you change the confidence interval? Like, can you play with that?
Yeah, I believe you can. I think we do that a little bit later in this. But yeah, you can play with the confidence intervals to get kind of different like lengths, I believe, like 99% or 95%. I can't exactly, I forget exactly how to do that. I apologize.
It's level.
Level?
Yeah.
So just level, then,
Yeah, default is 0.95
yeah,
or 0.95. So
just do
level without the S.
thank you. That's much bigger. Everything's just one thing. Okay, caps out. So yeah. Okay. And then we could add additional colors based on, say, the size of the value of z, which is x squared. So here it's color coding them based on the value. So, any questions so far?
I have a question with like way far back. For G0,
Yeah.
when you said x equals x and y equals y, what does that mean?
So that's telling it that in the data frame, the values that are going to go on the x-axis are x of that data frame. So there's a column in
okay.
there's a column in DF called x, then it's saying that in y the data frame y.
Okay.
Sorry, the values from the column y. All right.
So where is that data coming from?
We created it within the first code chunk. Yeah. It's fake. Okay. So we have our color coding. And then we can annotate with different labs. So it's the lab, you can pass them the title, subtitle, caption, X, Y. You can see it says you have X coordinate, Y coordinate, ggplot2, graphics example, and then we have the HIVR workshop. So there's a lot of like different kind of easy functionality and like things you can add to these plots. Yeah, what's up?
Question, the color is the Z or blue or how?
Yeah, so it's based on the value of this. Where,
Yeah, I know how. But,
yeah,
so that I would like instead of blue, have it green or.
yeah, so that's something that you can play around with like scale and whatnot. So. It defaults to this,
Oh,
it's the default, but it's something that you can change. Yeah. So you could have, yeah, like red be bright, and blue would be low. So that's an option. Okay. And if we want to get rid of, say, both the legend, the Z, it's guide. So guide, call for color, we say false. Oh, that's interesting. Okay. So this is something, so one of the things that I find annoying about tidyverse is they're constantly updating it and changing how they say their language, like how different wording that you need to use to get things to work. So this is an example of that, where it says, don't say this anymore, say this other thing. So you can see here, right, it's dropped it, it's gone, there's no longer that legend. So what somebody at our studio wants us to do now is say this. Where basically, instead of saying false, you say none, and that's telling it no legend. So I think if you recall correctly, see if I get this. Okay. Cool. But yeah, so that's just some stuff within tidyverse that sometimes you have to keep an eye on because they're always changing things and saying that functions are put out to pasture and whatnot, and you have to use new functions. So, okay. Any questions so far? No? Okay, and so themes are kind of overall looks of the plot. So we can do theme plus minimal. So you can see it's kind of gotten rid of. Let me put them side by side. Well, not exactly side by side. So before you kind of had this gray scaling in the back. You do theme minimal, it kind of gets rid of that, just has the lines. Do theme line draw. So here you can see the lines, right? You see like it's very dark. You do theme dark, which is just everything plotted on a much darker scale. And then there's other ones as well, and there's packages where people write different themes. There's some for like theme publication that you could use, because some journals don't like the grayscale, the back. Or some journals charge for color, even though I don't think any of them print anymore. So, there's different things you can play on these like grayscale, right, and whatnot to get around. Okay. Any questions before we get into facets? Okay. So facets are kind of how you can like make parallel plots. So this is kind of that par MF row thing that we were doing earlier, but for specific categorical levels. So you do G4 plus facet wrap. Facets equal G, so that's telling it, remember there's this variable G that we made in the data frame, and it's going to separate it out and plot them in each of them. And then also, it's gonna fit that linear smoothing line in within each of those passes. Kind of saving us the time of having to do each of those in LN one at a time. All right. Okay, I was gonna do something, but we asked you to do it as an exercise, so I'm not going to. All right. So that's facet wrap. You can also do. This kind of function G, kind of get the same thing. Okay. Facet grid. So this is say gonna make kind of grid it out. So this is sometimes useful if you have say two categorical variables and you want to have the different levels of one categorical variable on the x-axis, like the x plot rows, and then another one on the other axis. Oh man, it stopped working in the video. That's why it's doing that. Okay. So you can see facet grid G. So now we put it on the left hand side. So it puts as the rows. Any questions so far on that? No. I heard it.
You're just changing the order?
Yeah, you're just changing it. You're putting it on the column from the row. Yeah. That's it. Okay. So, next we'll play around with some scales, right? So this is how you maybe get different colors or shapes or scales of X or whatnot by the different levels. So we're gonna make this G4 again. So you see GG plot DF. We have the passing, we go AES, X equals X, Y equals Y. Instead of Z, we're gonna use G now. So it's a call equals as dot factor G. Genome point, genome smooth, our labs, our labels, our facet grid, and then our guide at the bottom, which I'll just change to none. So, all right, and we get that plot kind of messing around with. So now though, instead of D, right, we change to have the color be this fake G variable that we made, and so now everything is color coded by G. If we didn't have the guides, color of none, that would have like a little thing at the bottom where it's like red is 1, green is 2, blue is 3, purple is 4. But in this case, right, it's kind of self-explanatory given where the spots are. Okay. So start with G4, right? So this is our plot. So we can do scale color brewer. So this will just like give us this default colors. So this is from the R package we loaded at the beginning, our color brewer. And we can say, all right, we want the scale to be sequential, be based on these reds. And it'll give us kind of a sequential red color from 1 to 4. The qual, we're going to say 2. So this is another kind of brewing color that we can use. Div. And so what these are coming from is the this brewer, the color brewer, has all these different preset colors that they can essentially use. And they have them set up as sequential, qualitative, or divergent. So these are all the different colors that are already set in there, like color scales. So you can have yellow, orange, red, yellow, orange, blue. What's that, purple, blue, green, blue, blues, set. And spectral. So there's all these different kind of preset color scales that you can use for when you have a category, if you want to kind of have different scales, say going from one to the other. Say going from, you know, for example, spectral, right, going red to purple, or, you know, red to gray. But if it's like category, right, with distinct levels, maybe you want to use something in the middle. Yeah, so it's kind of a nice different way to get, you know, use some already preset, maybe some work in terms of like having a scale of color. So, any questions on that? No?
Well, can you make your own?
Yeah, I don't know. Yeah, you could kind of set your own manually, where you could say 1 is equal to red, but it's no longer that way that I was talking about. So let's see. Let me check to see. Like I maybe forgot. We maybe go over that. Nope, we don't. Yeah.
I have a question for that example that you're just up there,
Which one?
that you said, the previous one,
This one?
it says, collect two.
Yeah,
In the, brewer,
the brewer,
yeah, what
Okay, let's
corresponds
see.
to collect two?
green, orange, blue. I believe. I need to recall, sorry, let me see what I think it's. Francis, do you recall? So this is sequential. This is qualitative. Right? And this is divergent. So I'm guessing it's set two.
Set two.
Yeah. And so you could set these manually. So sorry, this is it's scale for yeah. And then you would say breaks, so like if you wanted it to be different, if you wanted to. It'll kind of flip them around, right? So it just maps to. So if you recall, we did this kind of with the iris, right? So this would be a faster way to do that in ggplot. Okay. Moving on. So, and these scales can also be used to change, say, the Y values. Say if you want everything to be on the log 10 scale, right? It'll now, you'll put Y on the log 10 scale. You could also change the X scale if you wanted to with scale X. Let's do square root. It'll change the X scale. So these are ways that you can kind of play with what the data looks like, especially with the log 10. Sometimes that's used in like basic science, right? Like lab and sequential dilutions and whatnot. All right. So genomes, we've kind of gone over this already. So genome point, genome line. Genome line is just connecting the points sequentially. Genome density. So what this is doing is it's taking X. It's going to be X is equal to Z, which is X squared. And then the fill is going to be G. So we're adding genome density. The alpha is I believe that's how seeker the data is, and then the guides, whether or not you want the guides for the alpha values. So so this will give us kind of the density of the data, which is kind of nice.
When you're saying plus, is that just like adding another layer on?
Adding just another layer. Yeah. Yeah, thanks for. So yeah, so it's very similar to kind of the pipe in tidyverse, only you're doing the plus to kind of add stuff on. Right. We can also make it so we can get like two-dimensional densities. Right, and we can add rug. So rug is just saying where are their points along the bottom line. I've never made one of these plots. Yeah, and just a reminder, just what the data looks like. I guess I'll throw this in here. Quick divergent. Sometimes if you ever want to like use broken it up and it's got like all these different pages and whatnot. We can sort everything. There's a lot of different options, but this is like a way to say if you want to have a matrix or a data frame within your R markdown or something that you want to display, as opposed to like the base R and also have it be a little interactive. That's a complete side. We're not going to talk about it again. Oh. Okay. All right, so genome bar will kind of show the counts. So ggplot df AES x equals G. Genome bar. Look at that. We got the different the values there. We got the count, how many G's there are each of these. So count, so the weight equals Y, so this will now sum over the Y value for each of those levels of G. So what this is doing is it's taking all the Y values where G equals 1 and it's summing them. It's taking all the Y values where G equals 2 and it's summing them. Taking all the Y values where G equals 3, summing them. Okay. Or at least that's what I've told you. Yeah, okay, that's what it's doing. All right. So if you already have something that has counts, so let's say you had this DF underscore, which is a tibble where we have A, B, C, and it's 10, 14, 18. So this is already you've counted some data that you want to then pass. You would just pass that and say stat equals identity. And that's just telling it, just use the value. Don't count or anything. If you didn't have that, I believe it should show. Oh, it gets in here. All right, so never mind. Yeah, so this is basically just putting 10, 14, 18. Any questions so far? Okay. So next off, we're gonna do this genome box plot. And we're gonna add points to it. We're gonna use jitter, which is jitter these points. So ggplot, yeah. We get this plot. So you see G, and then it's overlaying the points Z over each of the levels. So if you didn't have that, right, it just stacks them. Like width equals 0 means no jitter, right? Just automatically are, and you get this kind of. So this is because sometimes we use jitter more for visualization. Yeah. We could reduce the jitter, so the width, right? 0, no jitter, increase it, more jitter. So we could, make it ridiculous. In 0.5, or just make it 2. And it's going to be just a mess. So, and then if you want to make the jitter the same each time, you can pass in a seed. So that way each time it'll jitter it the point exactly the same. Trying to get the same point each time. You could try to make some of your plots reproducible. Okay. Chord flip, COORD_flip. Can anybody guess? Flips the coordinates. So it just put everything on top. Well, it flips it. And then if you want to save, you have to use GG save now. And so if you don't specify anything, it'll just save the last plot that was created. Go to files, digs, box. This plot that we just made. If you want to save a specific plot, right, and you assigned it a value, you say G3, say it as a PDF for some reason, right? And this is what G3 looks like. Okay. And then likewise, this is how you, you put those files that you just made, the plots you just made into the document. So. Let's save this. I'll just change this to PNG. Yeah, there we go. Okay. Any questions about ggplot? A good there is a good book called the ggplot 2-book. It's free online. I believe it's by a lot of the tidyverse people. Yeah, Hadley Wickham. And Danielle Navarro and Thomas Lynn Peterson. And this is a very useful resource if you really want to just go through and learn more about how to do different stuff in ggplot. Definitely when I started I just kind of went through this and just did the examples and followed along. This is a good resource to kind of have if you're curious about how to, about other aspects of ggplot. Any questions? Before we move into the exercises? No? All right, there should be a bunch of exercises at the bottom. They should look very similar to the base, but now use ggplot. I think it's the same question. Now do it in ggplot.
I think I'm just going over and doing and then. Yeah, I guess there's a local candidate, there's a working direction that starts to be where our project is, there's. If you want to save and that, we should get into more of a, I guess a more of a detail, file. Yeah. So it's very. Thank you.
Yeah.
There's like a dark version. That was so good. Very much fun to know. Oh, no, but.
Thanks.
I think Kelly, so, you don't know this, can you? I think it's supposed to send them out. I have the email here. Yeah, no problem.
Yeah.
Yeah.
So this is, you don't even have to, when you, you don't have to. So within the data frame, there's a column X, right? They need to add. So AES will know that the.
I don't think I understand that, so like.
Oh, so. Yeah, so instead of, oh, actually, I guess I. So what it would be. Iris. And then we go blue, that's X equals. Delta. Y. Does that make more sense? So it's like it knows within Iris. There's a call. So GG cloud. Figure that out. What else?
Yeah. You don't have this. You don't have to do nothing. It's gonna be, all the time. And you can do it. Yeah. Yeah, but I don't know.
No, that's a real. But also.
Yeah.
Over. These are the scenarios.
Oh, she said I want one. Yeah. Not that one. That's you need to read that paper. Yeah.
Okay, I was looking at the first one where.
Oh.
But I guess it's just that.
Yeah.
Oh.
Yeah.
Oh.
Yeah. Yeah, no worries. Yeah, you don't have to read it.
Okay, I'll look at it.
Yeah, just part of the box. Oh. You have a bracket on every side of the bar.
Oh my gosh. Okay. Oh, there it is. The species, one to each color is a different policy.
With another, with default, you don't have to use dollar sign. Because you see how you have the iris there.
Oh, I see that vision.
Did you read the whole thing?
Yeah.
I guess it's useful for you to getting back to.
Yeah. Yeah. Alright. Let's go, how are people doing? Do one more time, or should we do the answer? Go, well, not the answer, but walk through.
Sorry, what was the question?
Oh, yeah, do people want more time, or should we just walk through the, or we just go through these?
The latter.
Go through them, all right, let's go through them. So. First question. Plot a scatter plot of petal width versus petal length. So we go iris, GG plot, AES x equals petal width, y equals petal length, and then geom point. That gives us this plot. Okay. Something that's kind of useful when you do it this way is sometimes RStudio will be smart enough where it'll know what the columns of iris is, so it'll kind of, you can kind of type some of it and then tab and fill it in, which is nice. Add a best fit line to the plot. So we go iris, GG plot, AS x equals petal width, y equals petal length, geom point, then plus geom smooth. Right? So that's that best fit linear regression line to the plot. Yeah.
Okay. I guess. Why don't you put like formula, iris forward, so the iris?
It defaults, so it'll just default and be like, what's in X and Y, and just kind of put them in.
Okay. You are only to explain it.
That's the confidence interval level, like 99% confidence interval. So it defaults to 95, I believe. And you can see here, it actually even popped up a little message here saying, hey, we used this formula, but you didn't specify it.
If I put in like X and Y as like like,
Yeah.
and like the line actually didn't come up.
Oh,
I guess that like breaks it somehow.
yeah. So yeah, so I think that's my guess, is it wants whatever is in the, you pass it. So yeah, it'll kind of base on what is Y and what is X. So create a box plot of petal width by species and another box plot of petal length by species. Make these plots side by side. So how we did this, take iris, we pivot it longer, we pivot petal length and petal width, 3 bars and inches. So this is taking that data frame, right? Then we're pivoting it. So now we have petal length, petal width, inches.
Oh, no, it's just fine.
Okay. So on and so on and so on. And then we do ggplot. So I'm gonna put Y here. G on box plot. Facet wrap. Bars, and you can see it's kind of got that, the different, them side by side. So, you know, sometimes it makes sense, like you want it to be the same, right, between plots to make it easier to read. You know, like to draw if you're looking pedal length to pedal width. But if you wanted to say have them on different scales, do scales 3x, 3y. So now it's got them on different, so the pedal width is on a different scale. So in this case, right, the scale, they're both on inches, so it maybe makes sense to have them be on the same. But there could be instances, right, where they're different units or whatnot. You may want to do something like this. But you're gonna have to probably make it very clear to whoever you're showing the plot to that they're on different, you know, scales. Any questions on that? No? Okay. So create a scatter plot of pedal width versus length and color / change the symbol by species. So we do iris, ggplot, AES, pedal width, pedal length, color equals species, genome point. And look at that. We get red, green, blue across the different species. All right. Any questions on that? And I'll upload these answers to GitLab. So next, add best fit line for each species to this plot. So this is another one, defaults. So it'll just figure it out. Hey, said color equals species. We'll just draw these lines within each level of that species. The factor. So you can see here, it's now got those 3 different lines, right? So remember, we had to do this piece by piece. With base are, it's a lot easier, and plus you don't have the lines drawn out to infinity, right? ggplot cuts it off at whatever the last kind of observed value is on both the x side. Any questions? Okay. Save this out. GG save. Then read it back in. I'm just going to copy this code from over here. See, it's plotted it in there. And also, oh, that's cool. You can, within the visual mode, there's apparently options to just kind of play with the size. So you can kind of stretch it out if you want. What have you. Change the dimensions. So I did not know that. That is very cool. This is why we teach. Learn something new. All right. So underscore histogram. So you go iris, ggplot, x equals pedal length, say fill equals species, and we say genomes. Look at that. Look at our histogram, color coded by the different species for petal length. Create box plots of sepal width by species. Do the chord, so here we have sepal width. That's X and Y equals species, color equals species. And you can see the jitter. So I believe, let's look at this point. Yeah, so you can see like the jitter is slightly different because we didn't set a seed. Just looking at this guy. Kind of moves it around each time you run it. So that's one reason why you want to put a seed. Sometimes if you're doing like genome jitter. Then if we want to facet, do a plot faceted out species, we get this. So we get the petal width, setosa for secular. Can anybody guess what you'd put in here if you wanted it to not have all three levels on the bottom? Okay. It would be scales equals 3x. And now it just pops it like that. All right. We have a ggplot resource here. Which has some more useful ggplot stuff. In addition to that book that we kind of talked about. So yeah, that's what we finished 25 minutes early. Hopefully that's okay with everybody. Does anybody have any more questions or whatnot? I'm happy to answer any if I can off the top of my head.
So when we see the answers, when you upload them.
No, they should just, I'll just upload them to GitLab, and so the next time you pull, they should just be in the visualization folder. So I remembered it. I'll do it today. Yeah.
How do you compare ggplot with the Python packages for graphing?
Yeah, I don't really mess with Python that much, so I can't really answer in terms of the direct comparisons. My guess is the Python plot is probably from the same family of languages, like they're either one is mimicking ggplot or they came from like the same parent in terms of like thinking of evolving, like how to do like, plotting stuff. But I don't know with Python how it works. Yeah, sorry.
And when we used pivot longer.
Yep.
I guess, how would you see what the data frame looked like before you pivoted and after?
Yeah, so you head of iris, right? So showing what it looks like before. And then if we want to see what it looks like after, we could do this. We could set this to something, right? We could set it like iris longer. I'm just gonna pass like pipe to head. And so you can see kind of what it looks like now, where you got the 5.1, 3.5, right? Before, so that's still there, because that didn't get pivoted, but then you have setosa, then you have petal length 1.4, and then petal width 0.2. You say row. All right. Well, that didn't work. Oh, yeah, there we see the row column. So you see now it's like kind of like, okay, that was row 1 originally, right? That was row 2 originally, row 3. Anything else? Question? No? All right, well, next week is, I think HIV examples, I think Janice is running. So, you know, that should be, in the front and real data. Well, the iris data,